So the third kind of reaction we're going to discuss are oxidation-reduction reactions. We oftentimes call redox reactions, all right? Now, some redox reactions involve the transfer, marker out. Some redox reactions involve the transfer of electrons between species to yield ionic products. For example, if I take sodium solid and I treat it with chlorine gas, which is going to be nasty, you can imagine, I'm going to get a bunch of sodium ions and a bunch of chloride ions, right? So I took a neutral compound and I made it charged. So I yield ionic products, and this is a redox reaction, okay? It's oftentimes helpful to set, matter of fact, I'm going to say very helpful. It's oftentimes very helpful to split the overall reaction into individual equations called half reactions. This is going to be a little counterintuitive. And what's a half reaction, right? It seems like you can't have a half reaction. But we're going to call this a half reaction. We're going to say sodium solid starts out as neutral, and it goes to +1, and there's two of them, right? So that we must be stripping 2 electrons away from sodium, right? And here we've got chlorine, and there's 2 atoms here, and they both get a negative sign, right? So look we must be adding 2 electrons there. So this is going to be called, you know what, I've got that for the next page, all right? So the sodium loses electrons, and the chlorine gains electrons. Now, oxidation, watch this. Oxidation is loss of electrons. Reduction is gain of electrons. That's how I remember it, oil rig, okay? Oxidation is loss of electrons. Reduction is gain of electrons, right? Oxidation is loss. Reduction is gain, okay? And so in that case, then, the sodium is oxidized and the chlorine is reduced, all right? Now, since the chlorine is reduced, then sodium is the reducing agent, since it provides electrons, or it reduces chlorine, okay? So the thing that's oxidized is the reducing agent, and the thing that is reduced is the oxidizing agent, okay? Because it removes electrons from sodium. It oxidizes sodium, and so it's the oxidizing agent, all right? Now, some redox reactions do not involve the transfer of electrons. For example, if I've got H2 and Cl2, I can make hydrochloric acid, or hydrogen chloride. Since it's a gas, we don't call it acid, right? We call it's hydrochloric acid. The product of this reaction is a covalent compound, so we would not say that there's a transfer of electrons. That's not the best way to say it. But you can, if you look at the oxidation number of each atom, you would find that the oxidation number was changed, the oxidation state. What is the oxidation state? It is the charge that its atoms would possess if the compound was ionic, right? So if HCl was ionic, you would know Cl would be chloride, right, if it were ionic, and that would make hydrogen must be H+, if it were ionic, right? And so the oxidation state, or the oxidation number of hydrogen in this case, is minus, and the oxidation number of chloride is minus. I don't know if I said that right. The hydrogen oxidation state is +1, and the chlorine oxidation state is -1, because that's the charge it would be if it was ionic. So in our next conversation, we're going to talk about how to assign oxidation states for more complicated compounds.